Okay, so this is just really quick video and I'm just shooting it in 1080p to just save space. Now real quick, this is called a breadboard and it is just used to connect circuits. Like, it's mainly used for prototyping. I usually use it for prototyping. This is a smaller cousin of the breadboard. Like, this is a smaller version of the breadboard. You can see the breadboard contains a double-sided tape at its backside, but this one I have just removed it. And you can see all those exposed rails on the breadboard. I'll just give it a quick focus. You see these points right here. Just a second. These points right here, these rails, these are connected. These are connecting all these dots together in the vertical row. If you are holding it like this, all these dots have been connected by the rail at the back. All these dots have been connected by the rail at the back, this metal rail right here, with each other. So basically they are just short circuited together. And over here you see there are these two long rails over here which shorts these all these contacts over here. You can see real quick. This is where you basically plug your male wires or your ICs and resistors, etc. on the breadboard. Basically it helps you to like make a circuit without soldering, because generally what you do is you solder a circuit. Like, I have this circuit right here in my hands, just that I have soldered. So instead of soldering and making it just permanent, so you just assemble it temporarily so you can see all the working of the circuit and also probe different things using an oscilloscope. This is my PC oscilloscope. Another thing, this breadboard right here, all these rails are connected, all these points, these dots are connected to one another. These dots over here are connected to each other on the bottom side of the video, and on the top side of the video these dots are connected to one another. These are not internally shorted, these two. Same goes for here. These dots are connected to each other, these dots, but these are not shorted with these two. These two rails are not shorted with each other, right? So it provides an insulation between these two. Now, how do you plug anything in the breadboard? I'm just going to show you real quick. Now, for example, I have this IC over here. There's an integrated circuit. I don't know what it's for. I just took it out. Okay, so it's a serial to parallel shift resistor. So it's an 8-bit shift resistor. This is an IC. You can see all these pins over here. Now what you do is, on the breadboard, you just place your IC on the breadboard like this and just press it in. So it seats itself in the breadboard. Now you see the top rails are separated from the bottom rails. There is no connection in between over here. As you can see in this small breadboard, there is no connection in between these two. Okay, so basically what we have got is, we have got all these points to connect different wires to this pin of the IC. This is a single pin of the IC. So you have got all these points to connect different pins, different wires to the IC. So this is what the breadboard does. It basically provides you a platform on which you can connect multiple wires to a pin and also assemble your circuit so it looks a bit aesthetically pleasing, instead of just assembling it in on air. I'm sorry. I haven't planned this video, so I'm just not able to speak really well. I'm very sorry for that. Also, these are some of the resistors. I'm just going to show you real quick. Like, for example, this is a 10k resistor, 10 kilo ohm resistor. Okay. Crap. Where is that? Okay. There you go. Now, for example, if you want to place this resistor, if you want to just place the resistor on a breadboard, you do is you just place it alongside a hole and just press it in. Now this resistor over here, I'm sorry if it's not focusing. Now this resistor over here has been connected to this pin of the IC. This pin of the IC has been connected to this resistor, and now all these dots over here have been connected to this resistor through this lead. Alright, I hope you are able to understand. This goes same for the capacitors, inductors, etc that you are gonna place on the breadboard. Just now you might be asking a question that, whoa, Pranay or Fire Racer, whatever you would like to call me, that why haven't you told about the wires that you're gonna place on the breadboard? So these are called the jumper wires. It's a male to male jumper. You can just identify it by the leads that are protruding outwards. And real quick, I'm just gonna show you the female to male jumpers. You can see this is a male to female jumper. Alright, so these jumper wires are basically used to connect different things on the breadboard. Basically we use male to male jumpers to connect each and everything on the breadboard to itself. For example, like if I want to connect the last pin of this IC, I'm just gonna press this in, and on the other hand I'm just gonna connect this pin of the IC to here. Now these two pins of the IC are just shorted together. These two pins are just shorted together with the help of this wire. This is called a jumper wire, and obviously it's really easy to understand why it's called a male or female jumper wire, so it's not just a really big deal. So this is called a female jumper wire, and what I'm sorry if you're not gonna there you go. This is called a female jumper wire, and basically you can also extend these wires by using this female jumper wire. You can just connect the male to the female jumper wire, and now you have got a really big male jumper wire. Okay, there are also another kind of wire that we use to connect different things, like not permanently but temporarily. These are called the female to female jumper wires. You can see there is no pin on both sides of these wires. Okay, now what you usually do with the breadboard is you're just going to put your supply voltage over here. The supply voltage goes to these rails, so all the components can avail this supply voltage. So basically over here you can see all the smaller breadboard, it's labeled where you have to put in your positive. Here you have to put in your positive leads, and here you have to put in your negative leads. So if you put in your negative leads over here, all these are going to get negatively charged, and these are going to get positively charged. All these are going to be positive in potential. I'm sorry, they are not going to be charged, they are going to have positive potential. So over here it's not labeled, but on the outer side it's usually the negative that we place, and it's not a hard and fast rule because it does not matter. The breadboard is just an interface, it's not an electronic device really. So I'm just gonna show you one more thing real quick. Now for example, once you have decided how you're gonna just place all the components on the breadboard, then you can just solder these components onto a piece of perf board. That's called a perforated board, also called a PCB, printed circuit board, but this is not really a printed circuit board, it's a prototyping board that has copper dots on it. You can see, I'm sorry if it's not auto focusing. Yeah, there you go. So you just solder it like this, and you have got yourself a really nice project. So guys, I just thought that you all might not have been feeling very confident in using a breadboard, so I'm just gonna show you a little proof of what I said, that how are the pins connected on the breadboard. So over here I have a multimeter, and I've set it to continuity mode. You can see over here it's a continuity mode, it's set to, let me, okay, it's okay. So what I'm gonna be doing is I'm gonna use one female wire. I'm just gonna use male to male jumper wires. I'm just gonna connect these to the alligator clips of my multimeter. You can see over here, and another one again to the multimeter. Now whenever I short these things together, it will just create a continuity, and the multimeter will beep. There is a bit of high resistance on these leads because these are just really thin leads and these are not meant to carry a lot of current, so that's why they have resistance. Now I'm just gonna probe one end of this thing over here. You can see over here where I've probed it, and now I'm just gonna check all these points. You see it's continuous over here, but if you place it here, it's not continuous. Now it goes all the way up to here. It is continuous over here, but not over here. Over here it's not gonna be continuous. There is no short circuit between these two rails, and also there is no short circuit between the rail in front of this rail. You see over here, I've just marked the line over here. Over here you can see there is no short circuit between these two rails. Now if you are gonna be using another rail, I'm just gonna place it over here. Now you see it is continuous, continuous again, continuous again, and it goes so on, so on, so on. Yeah, I might be just boring some of you, but I'm just really sorry because I get a lot of students that ask me this question. So even I got confused at first when I was just using breadboard, and I think in my 8th standard or something like that, about these two rails over here. So now to use these two rails, I'm just gonna plug one of these, and you can see it's continuous up till here, and again I'm just gonna plug it here. There is no continuity between these two rails. And now if I just plug it over here, you see these two rails are just continuous. Now when it comes to here, I'm just gonna probe a random location on the breadboard. I told you that it is shorted to all these pins in front of it, not over here, not to its side, and not to its left. All these pins over here are connected to one another. I'm just gonna show you that. You see I've connected this over here. Now I'm just gonna connect it over here. You see there's a strong connection between these two, and now I'm just gonna connect it over here. Voila, there's no connection over here, and voila, there's no connection over here. You see also there is no connection over here in these two rails that are on the opposite side of the breadboard. That's how you're gonna place your ICs and Arduinos, etc. on the breadboard. So that's just really a basic concept, but some people just get confused in these concepts. It's okay because not all of you are just using breadboards since your childhood. So just gonna show you one more rail over here. You see continuous over here, but not continuous over here and here. Now this is just pretty simple concept. Now I'm just not gonna bore you with all these things. Another thing that I want to show you is how you place capacitors, etc. on the breadboard. Now over here I have some capacitors. I don't carry a lot of capacitors with me, but because like they are hell expensive in India. But yeah, for all my foreign viewers, like yeah, you people must have all the capacitors in the world that you can think of at your house. So okay, over here you can see this is a capacitor, and the value, this is an electrolytic capacitor, so it is basically polarized, which means that you cannot just flip its polarity. So you can see a negative is marked over here on this lead. To connect such type of capacitors, you just insert it onto the breadboard like this, and now it is connected. Now you can see it's connected, and the leads of the capacitors can be you can connect further components to the leads of the capacitors by using all these different holes over here. You can see all these holes will be now shorted to the lead of the capacitors, and all these holes will be shorted to this lead of the capacitor. I think that's just pretty simple concept, and that thing just same goes for all the diodes. Now here are just a few of the diodes that I usually use in my projects. Some of them are just Zener diodes, and some of them are just high voltage diodes and high current diodes. For example, I'm just going to show you one beefy diode. Yeah, this is the most common diodes. This is the IN4007. This is the most commonly used diode that you are going to find. Now this one is also a commonly used diode, but not that common as the IN4100, that one. And let me just, yeah, here you go. You see over here, these diodes are just really beefy. Of course I haven't used them yet, because each of these diodes can carry a current of up to 10 ampere. You can see if you want to connect this diode, etc., Just you are just gonna bend the leads and just connect it over here on the breadboard. It won't go in easily because the leads are just too thick, because of course it's a 10 amp diode. So yeah, of course now I'm just done with my video. I think you are able to understand the concept. If you're not able to understand the concept, just comment me down on the videos comment section, and I'll just make another video if possible. Okay, thank you for watching, guys. See ya. Another thing that I forgot to mention is about microcontrollers. Like for example, this Arduino Nano. This is an Arduino Nano, and it uses a microcontroller that is called ATmega 328P. That's a chip that ATmL make, and it has a USB decoder on its back. So these boards are just really breadboard friendly. So you can just place them on the breadboard, and you can make different connections. These just go right in to the breadboard. Now you see it's all in the breadboard. Now you can just connect all these different pins to different things. Over here you just got yourself an expansion type of thing for all the connections. Secondly, here are some of the different ICs that I use. So these all just can go straight into the breadboard, and some of these are just like the 555 timer. This is the NE 555 timer, and some of these are just shift resistors, and some I also have a microcontroller IC over here. And just I'm going to show you, these are the 555 timers, by the way, and some of these are op amps, comparators, and what else, I don't know. It has been a while since I used this collection. Well, this is not exactly a collection. Just ask another electronics enthusiast and he'll tell you what is a collection of ICs. I don't know where the hell is that gone. Now these are called optocouplers. Sorry if you're not able to see them. These are called optocouplers, and you're just going to use them because they contain a triac in them. Triac basically consists of two diacs, etc. Yeah, you will just learn about them, and I'm not going to get into detail about that. But these are used for the phase angle control in the AC signals. Okay, see ya.